Hi, and welcome to the Test-Driven Development with PowerBuilder 2000 C IDE session. Here is a little disclaimer about the session. In this session, we will see what is test-driven development, how to prepare a project for testing, how to create an xUnit test project, how to run your tests, how to develop theories, how to debug your test, and some final notes. Here you'll find a little information about myself and some info about the company. There are several different coding approaches out there, but one of them is called test-driven development, or TDD. This session focuses on this technique that mainly relies on a very short repetitive cycle. Code your test cases or requirements, then develop your app to pass those tests. This approach encourages simple designs and inspires confidence. That is because you, the developer, can have better confidence that your apps are coded to work properly from the very beginning. So unit testing can be considered as part of the test-driven development approach, since individual units or components of software are being tested. So a unit is actually the smallest testable part of any application. Putting it in a simple way, test-driven development focuses on developing your test first or at the same time. Then develop your code to pass those tests. xUnit test is a framework that facilitates the unit testing tasks of a project. PowerBuilder 2019 C IDE integrates its own xUnit test so that your testing tasks can be easier. We will now look into a simple project named Calculator CS. It is a C# assembly. It is a simple calculator that will perform addition, subtraction, multiplication, and division. So we will now prepare the project for testing. So this is a look into the calculator.cs file. We need to add the actual business logic to it. So this is how the calculator class should be. As you can see, it is a very simple class. It only performs some very simple operations and returns the result of each operation. But this is enough to start using the xUnit test project. Also notice the use of the static keyword, which we will use to avoid having to instantiate later on. Now let's add a new xUnit test project to our solution. To do that, we would be doing this on PowerBuilder C IDE, and you would right-click on the solution, then click on Add New Project, name the project calculator.tests, and click OK. This will create a simple project with one class for the basic starting point of our tests. Since we will create our own class to test our code, we can proceed to delete this object. So right-click on the unit test1 CS object and then select delete. Then create your own class by right-clicking on the calculator.test project and selecting add class. Name it calculatortest.cs and click OK. The following code will be generated for calculator test class. Delete the test1 method and the fact attribute. Now that we have our testing class, we will create a reference to our actual development project. In order to do that, expand the dependencies item in the calculator.test project, then right-click on it and select Add Reference. Then you would select the calculator project and click OK. This will add the calculator project as a reference to our test. Here is where we start developing our first method that will test the addition method from our calculator class. The coding of our test will be done on the calculator test class, and any required changes to the actual app will be done to the methods of the calculator class. One very useful thing to keep in mind is a naming convention for our methods. One of these conventions states that you need to use the word should in the name of your test method in order to make it clear that the method should perform certain testing tasks. But for this session, we will use our own naming convention that will start with the name of the method to test, then a simple and short explanation of what it should do. So we will name it addition should calculate simple values. Notice that it returns void. This is because testing methods usually don't need to return any value. So this method will test the addition method. The testing methods usually have three main sections inside of its lines of code: instantiation, action, and assertion. In the instantiation section is where we set up what's needed for the test to run. The action section is where we actually run the method that we want to test, along with any other operations needed for it to run. Then in the assertion section is where we actually assert that the method should do what we expect it to do. For that, we will use the assert object. The assert object has many APIs that help you determine if the test passed or failed. You can find all of the APIs of assert using the Intelligent Code Completion feature of PowerBuilder 2019 C IDE. So let's add the code to our test method for the actual test. Notice how we decorated our test method with the attribute fact. That is because there are mainly two different types of test methods. Facts are tests which are always true. They test invariant conditions. Theories are tests which are only true for a particular set of data. We will start by testing a fact because we know for sure that 3 plus 6 equals 9. We'll test the theory after that in this session. So now click on the Test Explorer window or menu option to open the Text Explorer window. You will notice that our test already appears here. It's time to run our tests. Click on Run All in the Test Explorer window. Wait a couple seconds for the projects to build and the test to run. Then you will notice that the test has actually passed. This was an actual test that asserts that if you pass 3 and 6 to the addition method, it should return a 9. Even though this was very simple, it illustrates the basics of how facts are developed and tested against our code. But we will now perform a more close to the real-world test, where we want to test theories that challenge our code against several different set of values, thus actually testing different scenarios that our methods could, would, or should stumble upon. So we'll change our fact to a theory. Theories usually test different scenarios or values of data, so we need to pass these values to our test method. In order to do that, we use the inline data attribute. This attribute will set the different scenarios that will test the different values of our data. We will now add some of these scenarios to our method. Notice the changes we made to our method. We have added 3 new parameters in order to receive the values from our theory, plus calling our actual method. It passes the parameters, making it more real-world-ish. If we do a build to our solution, we need to press F6. You will notice that now each one of the inline data attributes we added have become tests in our Test Explorer window. Now, we can now click on Run All again to run all the tests. They should all pass. So far, we have tested theories that all pass, but what if one of them didn't? Well, that's the whole purpose of this approach. How to tackle a test that doesn't pass. What to do next? Well, let's see another test method example. If we do a build to our solution, press F6, you will notice that now each one of the inline data attributes we added have become tests in our Explorer window. We can now click on Run All again to run all our tests. You'll notice that one of them fails. But this is actually useful information because it is telling us that our method is not prepared to divide by 0 and return a 0. It is actually returning undetermined or infinite. This means that we need to refactor our code so that it can pass this particular test too. And this is where we actually make changes to our calculator class in order to comply with all the requirements or tests that our method should. Now here you see that we have refactored the logic for division by 0. So if we pass in a 0 and it tries to divide by 0, it would return a 0. And since we know for a fact that all divisions by 0 shouldn't return undetermined, but in this case it would return a 0, or at least for the purpose of this presentation, then we can make that the test a fact. If we do a build to our solution by pressing F6, you will notice that now each one of the inline data attributes we added have become tests in our Test Explorer window, including the division should divide by 0. Now we can click on Run All again to run our test. This time they should all pass, which is exactly what we are aiming for. Now let's look into how to debug your tests. Now that we have several tests, there may be the need to debug a test to make sure that it is actually doing what it is expected to do. This is actually quite simple. First, you need to add a breakpoint into your code. You can do that by clicking on the gray sidebar on the code editor window in the line you want to add to the breakpoint to, or by right-clicking on the line of code where you want to insert the breakpoint and then selecting Add Insert Breakpoint. Then right-click on the test you want to debug and select Debug Selected Tests. Now you can continue debugging your code as you would normally do. So, some final notes for this session. You should develop your code to pass your test, not develop your test so that your code can pass your test. You want to create tests for as many possible scenarios, facts, and theories as you can. This provides confidence that you will deploy better working code to production. Your testing project calculator.tests in this presentation is not necessarily needed in a production environment. In fact, in most cases, it can be a big no-no. xUnit test projects are actually projects that will assist you to develop better working code from the very beginning.